Hello everyone, this is Mr. Anderson, and we're going to look at the last example in Learning Target 6G. First, let me apologize. There is some construction noise going on in the background, so I'm really sorry if that's disturbing at all to you. You may want to turn your volume all the way up. We start with the definition, and that definition is of a composite function, or a combined function. We have a combination of two or more functions, and that's what we see here in example 4. We are, for example, going to have a function that is a parabola, but also one that is a hyperbola. All right, so we're going to be using those two things to generate a graph of a new function. This is going to look a little weird. Maybe you've never seen it before. But we start with the identification of our vertical asymptote. All right, a parabola, of course the parabola piece does not have any asymptotes, but this part, the hyperbola, is going to have one. And that hyperbola, that asymptote is going to be at, in this case, the point where it is undefined. And of course, you know that when we have a function like that with a variable in the denominator, we are undefined whenever it's equal to 0. Now there's nothing else in the denominator with it, so we can simply say we are going to have a vertical asymptote at x equals 0. This is pretty easy to graph and pretty necessary to graph, so what I'm going to do is I'm going to zoom in on my coordinate plane here. I'm just going to dash in that vertical asymptote at x equals 0. So there it is. I'm dashing that in, and of course it is a vertical boundary, so you do want to make sure that that you get it dashed. It's not a solid line. Zooming out, I can see that part B asked me to find the axes intercepts. Now check this out. Because we have a vertical asymptote that is essentially the y-axis, it's x equals 0, we're not going to cross the y-axis, which means we're going to have no y-intercept. All right? It's impossible to have one if we have an asymptote at x equals 0. However, we do have some x-intercepts, and I said some, there's really only one. We are going to have an x-intercept, and this is really easy to see if you simply enter the function into your graphing calculator and look in the table. So go ahead, type in x squared plus 1 divided by x in your graphing calculator, and simply go second in graph and go to your table, and you will see that if you scroll down to the value of -1, you have a y value of 0. Well, that by definition is your x-intercept. All right, so that's another important point, or an interesting point, that we should graph on our coordinate plane. I'm just going to make that dot at -1, 0. Okay, part C then says find the turning points. Again, you can find the turning points by using the graphing calculator, and I would recommend that you do. You can see if you graph it on the graphing calculator, we have a function that kind of looks like this on the left-hand side of the asymptote, and then something like that on the right-hand side. So there's a turning point right here, and that is a minimum. The reason I identify that that is a minimum is because you can then use the second and trace menu, or the calc menu, to calculate that minimum. And if you do that, press second and calc, find the minimum, select left and right bounds, and then guess where that minimum is. The calculator will do all the work for you. So my recommendation here is to do this with your graphing calculator. And of course, when we're using the graphing calculator, we say via GDC, and you want to use the minimum calculation option. So we do have a local min at, and I'm rounding this to 3 sig figs, 0.794 and 1.89. All right. So I'm going to go back in, zoom in on my graph here, and I'll identify that minimum. I go over 0.794 up to 1.89, so it's going to be somewhere right in there. Okay, there's no other max and min on my graph. No other turning points, no other intercepts. So now I'm simply resorting to the table. Press second in graph to go to your table, and the problem doesn't ask me to do this. This is something I'm doing to generate an accurate graph. I'm going to go ahead and plot every single point that's going to fit on my graph. So I start at -3, -2, -1, 0. Let's see, what else? 1, and then 2, and then, yes, 3 will fit. All right, so again, I'm pulling these right off the table feature on the graph. 8.67, and then 3.5 and 0, and this is going to be undefined at 0 because that's where we have that vertical asymptote. At 1 we're at 2, at 2 we're at 4.5, and at 3 we're at 9.33. Okay, so now I would just take all these points and simply graph them on my coordinate plane. Try to make it as accurate as possible here because you want to give yourself the best option to get all the points. So over 3 up 8.66. I think that's right about there. And then go over 2 up 3.5. That looks pretty good. Over 1, well, I already got the intercept plotted, so I don't need to graph -1, 0. But now I can go to the right 1 and up 2. I'm going to have another point right there. And then go over 2 up 4.5. I'm going to have something right there. And then I go over 3 up to 9 1/3. And that's going to be close enough. Now my only job is to make that graph look like what I see on the screen of my graphing calculator. And that looks something like this on the the left-hand side of that asymptote. And my pen isn't working great here. It's creating a dashed line. Let me see if I can fill that all the way in. Okay, and then on the right-hand side, I got this thing that kind of looks like a parabola, almost. And again, I'm struggling with the pen a little bit, so forgive me, please. But there we go. I now have a function that's graphed. Okay, I think I'm going to get all the points. I have my asymptote marked. I have my minimum marked, I have my intercepts marked, there's only one of them, but then I went ahead and graphed every single point in order to create the greatest amount of accuracy that I could. Thank you for watching this video. Tomorrow we will go over any questions in class, and tomorrow evening or afternoon at 2 p.m. you'll also have the opportunity for the 6G quiz. Thanks, and have a great day.